Dear students, in the last class, we learnt about the effect of temperature on rate of reaction and Arrhenius equation and concept of activation energy. Here, the effect of temperature on the rate of reaction was studied by Arrhenius. Okay. ಅಂತಂದರೆ ಎಫೆಕ್ಟ್ ಆಫ್ ಟೆಂಪರೇಚರೇ ರೇಟ್ ಆಫ್ ರಿಯಾಕ್ಷನ್ ಮೇಲೆ ಹೇಗಾಗುತ್ತೆ ಅನ್ನೋದನ್ನು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದ್ದೆ ಅರೇನಿಯಸ್ ಅವರು. ಸೊ ದ ಈಕ್ವೇಷನ್ ಕಾಲ್ಡ್ ಆಸ್ ಅರೇನಿಯಸ್ ಈಕ್ವೇಷನ್. This is the Arrhenius equation. K is equal to A into e to the power of minus EA by RT. Here K is the rate of reaction or rate constant. A is Arrhenius constant. EA is the activation energy. R is the universal gas constant. T is the absolute temperature. Okay. Using this equation, above equation, take a log on both sides. This is the equation. Here at two different conditions, if the values of the rate constant at temperature T1 and T2, comma K1 and K2, here ln K1 is equal to ln A minus EA by RT1, ln K2 is equal to ln A minus EA by RT2. Here subtracting 3 minus 2 equation, we get ln K2 minus ln K1 is equal to minus EA by R T2 minus of EA by R T1. So it gets a plus. So then ln K2 minus ln K1 is equal to, we take a common factor, that is EA by R, 1 by T1 minus 1 by T2. Taking a log on, convert a ln into log base 10, we get this equation. This equation we use to calculate the activation energy by knowing the rate constant and the temperature, or otherwise they gave only the one temperature, not given another temperature. So in that problem we have to calculate both activation energy and one of the temperature. So first we have to know the activation energy by using this equation. Okay. Log K is equal to minus EA by 2.303 RT plus log A. This equation is the straight line linear equation. Y is equal to mx plus c. In the y-axis we plot a log K. In the x-axis 1 by t. We get a slope, that is minus EA by 2.303 R. By knowing this, we can calculate a EA value. So substituting EA value to this equation, and then we have to calculate one of the temperature. This is all about the last class. So in today's class we learnt about we move on to the problems using these equations. Okay. In that, first one, K versus 1 by T graph. K versus 1 by T graph was plotted to calculated the activation energy, of a reaction using Arrhenius equation for the effect of temperature on reaction rate. Okay, here the slope of the straight line was found to be minus 2.55 into 10 to the power of 4. Okay, minus 2.55 into 10 to the power of 4. Full stop. Calculate the activation energy of the reaction. Here, this is the problem. You have to carefully observe. Here they were not given a different conditions. Reactions ಅಂತಂದರೆ ಎರಡು ಡಿಫ್ರೆಂಟ್ ಕಂಡೀಷನ್ಸ್ನ ಕೊಟ್ಟಿಲ್ಲ. ಅಂದರೆ ಎರಡು ರೇಟ್ ಕಾನ್ಸ್ಟೆಂಟು, ಎರಡು ಟೆಂಪ್ರೇಚರ್ ಆ ಥರ ಕೊಟ್ಟಿಲ್ಲ. ಸೊ ಹಿಯರ್ ದೇ ಆರ್ ಗಿವನ್ ಎ K versus 1/T graph was plotted. Okay, it means last equation. To calculate the activation energy of a reaction, we have to plot a rate constant versus absolute temperature to calculate the activation energy of a reaction using Arrhenius equation for the effect of temperature on the reaction rate. ಈ ಗ್ರಾಫ್ನ ಪ್ಲಾಟ್ ಮಾಡಿದ್ರೆ ಯಾಕೆ ಪ್ಲಾಟ್ ಮಾಡಬೇಕಪ್ಪ ಅಂತಂದರೆ we have to calculate the activation energy. Okay, here they give a slope only, not a rate constant or a temperature. Okay, here they are giving only a slope, so that's why the slope of the straight line was found to be minus 2.55 into 10 to the power of 4. So then calculate the activation energy of the reaction. Okay, next we will move on to the solution part. That is, here they are given a slope of the straight line. What is the slope of the straight line is minus EA by slope is equal to minus EA by 2.303 R. Okay, this is the slope of the equation. Okay, and then here the slope of the equation is equal to minus 2.55 into 10 to the power of 4. Okay, so you have to write again EA divided by 2.303 R ಅಂತಂದರೆ ಇದು ಓವರಾಲು ಏನಪ್ಪ ಅಂತಂದರೆ minus 2.55 into 10 to the power of 4. Okay, so is equal to minus 2.55 into 10 to the power of 4. ನಾವು ಈ ಈಕ್ವೇಷನ್ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಡೈರೆಕ್ಟ್ಲಿ ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೋದು. ಯಾಕೆ ಅಂತ ಅಂದರೆ ಇನ್ನೊಂದು ಈಕ್ವೇಷನ್ನ ಯೂಸ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಯಾಕೆಂದರೆ ಇಲ್ಲಿ ನಿಮಗೆ ರೇಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಕೊಟ್ಟಿಲ್ಲ, ಟೆಂಪ್ರೇಚರ್ ಕೊಟ್ಟಿಲ್ಲ. ದೇ ಆರ್ ಗಿವನ್ ಓನ್ಲಿ ದ ಸ್ಲೋಪ್. ಓಕೆ, ಸೊ ದ ನೆಗೆಟಿವ್ ಸೈನ್ ಗೆಟ್ಸ್ ಕ್ಯಾನ್ಸಲ್ಡ್ ಆ್ಯಂಡ್ ವಿ ನೋ ದಟ್ ಆರ್ ಈಸ್ ದ ಯೂನಿವರ್ಸಲ್ ಗ್ಯಾಸ್ ಕಾನ್ಸ್ಟೆಂಟ್, ದಟ್ ಈಸ್ constant value, that is 8.314. This is the R value. So EA divided by 2.303 into 8.314 is equal to 2.55 into 10 to the power of 4. Okay, so then this will goes here. So EA is equal to 2.55 into 10 to the power of 4. ಇಲ್ಲಿ ಡಿನಾಮಿನೇಟ್ರಲ್ಲಿ ಇರೋದು ನ್ಯೂಮರೇಟರ್ಗೆ ಹೋಗುತ್ತೆ, ಇಂಟು 2.303 into 8.314. okay, so by multiplying these values we get 4.88 into 10 to the power of 5. ಮನೇಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ. ಅಕಸ್ಮಾತ್ ಈ ಪ್ರಾಬ್ಲಮ್ ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂತಂದರೆ ರೆಗ್ಯುಲರ್ ಕ್ಲಾಸಸ್ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತಲ್ಲ, ಐ ವಿಲ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಯು ಅಗೇನ್. ಓಕೆ, 10 to the power of 5 joule. okay, this is all about the one of the problem on effect of temperature on rate of reaction. Here this is the problem. You have to observe K versus 1 by T graph was plotted to calculate the activation energy of a reaction by using Arrhenius equation. They given a slope. okay, so then slope of the straight line is minus EA by 2.303 R is equal to minus 2.55 into 10 to the power of 4. minus minus gets cancelled. R is the constant value, that is 8.314. ಅದನ್ನು ಜ್ಞಾಪಕದಲ್ಲಿ ಇಟ್ಕೊಳ್ಳಿ. ಆರ್ ಅನ್ನುವಂಥದ್ದು ಕಾನ್ಸ್ಟೆಂಟ್ ವ್ಯಾಲ್ಯೂ ಯು ಹ್ಯಾವ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್. ಸೊ ದೆನ್ EA divided by 2.303 into 8.314 is equal to 2.55. so by substituting this into the numerator, so we get this value. okay, next second one is the activation energy of a reaction. The activation energy of a reaction is 225 kilo calorie per mole. okay, 225 kilo calorie per mole, and the value of the here, sorry, not a 225, that is 22.5. 225 ಅಲ್ಲ, 22.5 kilo calorie per mole, and the value of the rate constant at 40 degrees Celsius is 1.8 into 10 to the power of minus 5 second inverse. okay, so then finally we can calculate the Arrhenius constant. Calculate the frequency factor. Frequency means collisions. How much collisions should be taking place? okay, and that is A. Frequency factor A. This is the problem. Here you have to observe the activation energy of a reaction is 22 point. Solution is the activation energy of a reaction is 22 point EA. EA is equal to 22.5 kilo calorie per mole. okay, and then the value of rate constant means K is equal to how much? Rate constant at 1.8 into 10 to the power of minus 5. 1.8 into 10 to the power of minus 5 second inverse. okay, so then here they given a temperature also. You have to carefully observe. T is equal to 40 degrees Celsius. This degree Celsius should be converted to Kelvin, that is 40 plus 273 is equal to how much? 313 Kelvin. Okay, then we have to calculate A, frequency factor or Arrhenius constant. Okay, here ಇಲ್ಲಿ activation energy na ಕೊಟ್ಟಿದ್ದಾರೆ. They given a activation energy and the value of rate constant. Rate constant is 1.8 into 10 to the power of minus 5 second inverse at 40 degree Celsius. 40 degree Celsius ಅಲ್ಲಿ rate constant ಎಷ್ಟಿರುತ್ತೆ ಅಂತ. So then calculate the frequency factor. Here this 22.5 kilocalorie per mole, that should be converted to calorie per mole. It means it is multiplied by ಕಿಲೋನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. 22.5 into 1000 calorie per mole is equal to how much? 22,500 calorie per mole. ಓಕೆ, ಇಲ್ಲಿ ಒಂದು ಪಾಯಿಂಟ್ ಲೆಸ್ ಆಗುತ್ತೆ, 2 0 ಜಾಯಿನ್ ಆಗುತ್ತೆ. ಓಕೆ, ದಿಸ್ ಇಸ್ ದ ಡಾಟಾ. ಓಕೆ, ದೇ ಆರ್ ಗಿವನ್ ಇನ್ ದ ಪ್ರಾಬ್ಲಮ್. ಸೊ ದೆನ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟಿಂಗ್ ದ ವ್ಯಾಲ್ಯೂಸ್ ಇನ್ ದ ಈಕ್ವೇಷನ್, ದಟ್ ಈಸ್ ಲಾಗ್ ಕೆ. ಲಾಸ್ಟ್ ಈಕ್ವೇಷನ್ ತೊಗೊಳ್ಳಿ, ಯಾಕೆಂತಂದರೆ ಇಲ್ಲಿ ಡಿಫ್ರೆಂಟ್ ಕಂಡೀಷನ್ಸ್ ಕೊಟ್ಟಿಲ್ವಲ್ಲ. ಸೊ ದಟ್ಸ್ ವೈ ಯು ಹ್ಯಾವ್ ಟು ಟೇಕ್ ಎ ಲಾಸ್ಟ್ ಈಕ್ವೇಷನ್. ಲಾಗ್ ಕೆ ಈಸ್ ಈಕ್ವಲ್ ಟು ಮೈನಸ್ ಇ ಎ ಡಿವೈಡೆಡ್ ಬೈ 2.303 RT. Okay, plus log A. Okay, here we have to calculate log A now, so you have to keep this here. So substituting this into the here, so negative value you should convert it to positive. So log A is equal to log K plus EA divided by 2.303 RT. Okay, we know that R value is 8.314. Okay, so this is the equation. Substituting these values to this equation, so you can calculate a log A, that is log A is equal to log K means 1.8 log 1.8 into 10 to the power of minus 5. Okay, plus EA means 22,500. 22,500 divided by 2.303 into R is 8.314. 8.314. Then temperature is 313 into 313. Okay, this is the substitution. Here log is log mn. Okay, log mn allide, so you have to substitute log A is equal to log 1.8, that is log mn means log m plus n plus log of 10 to the power of minus 5 into plus, sorry, not a multiplication, that is plus. ಈ ಓವರಾಲ್ ಆಗಿ ಎಷ್ಟು ಬರುತ್ತಪ್ಪ ಅಂತಂದರೆ 15.7089. ಓಕೆ, 15.7089. ಸೊ log A is equal to log 1.8 value means 0.2553. ಓಕೆ, ಲಾಗ್ ಕಂಡುಹಿಡಿಯೋದು ಗೊತ್ತಿದೆ ಅಂತ ಅಂದ್ಕೊಂಡಿದ್ದೀನಿ. ಲಾಗ್ ಟೇಬಲ್ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಯು ಹ್ಯಾವ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಎ ಲಾಗ್ ವ್ಯಾಲ್ಯೂಸ್. ಇಫ್ ಯು ಆರ್ ಗೆಟಿಂಗ್ ಎನಿ ಕನ್ಫ್ಯೂಷನ್ ಐ ವಿಲ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಯು ಇನ್ ದ ರೆಗ್ಯುಲರ್ ಕ್ಲಾಸಸ್. ಓಕೆ, ರೆಗ್ಯುಲರ್ ಕ್ಲಾಸಲ್ಲಿ ಮತ್ತೆ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿಕೊಡ್ತೀನಿ. ಇಲ್ಲಿ ಜಸ್ಟ್ ತಿಳ್ಕೊಳ್ಳಿ, ಲಾಗ್ 1.8 ಈಸ್ 0.2553 plus this will log m to the power of n, that is n log m ಬರುತ್ತೆ. ಸೊ -5 log 10 plus 15.7089. So then log a is equal to 0.2553. This is -5. Log 10 means 1. Okay. So then plus value ಇಟ್ಕೊಳ್ಳಿ plus 15.7089. So then log a is equal to 0.2553 minus 5 plus 15.7089. So the final value is log a is equal to 10.9642. Okay, this is the log a value, but we have to need a value, not a log a. We have to need a value, so you have to substitute this log into here. So log is converted as anti-log. Okay, anti-log ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. So a is equal to anti-log of 10.9642. So a is equal to anti-log ಅಲ್ಲಿ ನೋಡಿದಾಗ we get 9.208. ಆ್ಯಂಟಿಲಾಗ್ ನೋಡೋದು ಗೊತ್ತಿಲ್ಲ ಅಂತಂದರೆ ಹೇಳ್ಕೊಡ್ತೀನಿ ಕ್ಲಾಸಸ್ ಶುರು ಆದಾಗ. 9.208 into 10 to the power of 10 collisions. Okay, we have to calculate a frequency factor, no? So that's why that is collisions. Frequency ಅಂತಂದರೆ collisions ಆಗುವಂಥದ್ದನ್ನು ಕಂಡುಹಿಡಿಯೋದೇ frequency, collision per second. Okay, this is the problem. Okay, here you have to carefully observe. They are given a value. This kilo will be converted, multiplying by 1000 we get 22,500 calorie per mole. Then k value, then temperature should be converted as Kelvin, and R we know that a is we have to calculate. This is the equation. By we need a log a value, so that's why I have to shift here. We get plus charge and substituting the value. This is log mn position, so log m plus n. So and in that this is log m to the power of n log m. Log 10 base 10 is 1 always, so that's why you have to keep a -5 as it is. This is the value we need, a value, so that's why you have to shift a log into this side. This converts a log into anti-log. This is the answer. Okay, collision per second, frequency factor ಅಂತಲೂ ಕೂಡ ಕರೀತಾರೆ, ಅಥವಾ ಅರೇನಿಯಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂತಲೂ ಕೂಡ ಕರೀತಾರೆ. ಓಕೆ.